Hey guys, how's everything going? Today let's continue our adventure on LeetCode. Let's take a look at number 76, minimum window substring. We're given a string and a string. Find the minimum window in S, which will contain all the characters in T in a complexity of ON. Like this, for ABC, the minimum string which contains ABC, which is BANC. If there's no such window in S and covers all characters in T, return empty. Okay, so we're already asked to finish our problem in the complexity of O big O n. So we need to do it with one pass. Let's compare a string like for this one against this one. If this one contains all the characters in this string, how would we define it? It means all the characters in T occurred in the characters in S, right? What if there's duplicate like A, B, C, B? That means that there must be double B in this string. It's also valid in our case. So our problem becomes we need to naive solution comes to mind that we need to count the occurrence of the string of the characters. If we loop through the characters in S like this one, okay, the first one is A. Okay, we met one A. A is in this string, in this target. Okay, we say, okay, we find one A, and then we meet D, O, which is not the target. We skip it, and then we find B. Okay, we find another B. It is still in our target, but there is only one B, and then we need to go to C, find another C, and then find another B, right? Then the B is here, yeah. And then we find that we found enough occurrence of our characters, and then we say this is a possible solution, and we can slice the string from the A here and B here, and it is a possible solution. And we can do this over and over again and get the minimum, gets the one with the minimum length, right? So the first thing is that we need to count the target string to see how many characters, what the occurrence of each characters, and then when we loop through the source string, which is S, we need to count that also, right? We meet A, we count it. We meet B, we count it, and we met C, we count it. But how can we know that our string, our conditions are matched? We cannot say we cannot generate the unique string like do the sorting and generate the unique string and match it, do the hashing or something. We cannot do that, right? So that leads us to extra complexity. So what we do here, I'm not sure whether it's the best solution, is that like first we know that the target is A1, B2, C, right? And then when we're counting our source string, we can define another set, which is the missing characters, right? The first for the initial case, so all the characters are missing. And now when we get A, because the target is only one, so we get one, so it's no more missing. So the next one is B, C. Now when we meet B, our counted, which is 1, and the target is 2, right? So it's still missing. And then got C, the count is 1, the target is 1, so it's not missing. And finally, we get another B, so it's no more missing. So this indicates that there is a possible solution. Okay, so we are this is how we define a possible solution. And when we have a possible solution, the first one, we can just safely remove it, right? Because in any other possible solutions, if we continue having the starting index as the previous one, it will be longer. There will be no more better solutions. So we just remove it and do the check over and over again, right? Yeah, so let's do it. Okay, we're sure that the first one we need to get the target and get the count, and then we get the missing. We need to have a missing set count, check against target. Okay, now the irregular cases, the edge cases, that if no such window is in it, then we return empty. So what if both of them are empty? Let's the final result is empty. If S is empty or T is empty, then we return result. Okay, this is the irregular case. Now let's generate count to the target. Our target would be a map. Okay, target equals new map. For let I equals 0, j I smaller than t.net. If target has I, okay, if it doesn't have it, then target set ti 0 or 1. For the other case, we need to set it to 1, right? A plus 1. So it will be target get ti plus 1. This is the target. Now we also have a count new map. We just set count set ti 0. Yeah, now we have count, we have target, and now we need to set the missing. Okay, the missing character. Missing, we use a set, right? We use a set to, because the counting problem will be done by checking target count versus target. So the missing characters equals new set, and we'll just add it to. Wow, this is a new feature from LeetCode, which is pretty cool. Okay, for the initial case, every characters in the T are missing. Okay, now let's traverse through the characters in the substring. Okay, J s.net, right? Okay, I'll still use I, which is more familiar to me. I++. The ending case, we check the last character. Checking the last character. Yeah, it's okay. Now the character, we cache it with si. Update the count. right? Yeah, if target has character, which is the target characters, which is in T, which means it is the characters in T, then we need to update the count, right? Count set character count get character +1. Okay, this is a new count. Now, if occurrence is enough, then we should say it is no more missing, right? We don't need any characters. Okay, which means if count get the character is bigger or equal to target get character, then it is no more missing characters. We can just safely remove it, right? We update the count. Okay, then if it is possible result, which means if missing character length equals 0, no, it's not length for set, it's size. If there's no more missing character, like for our case here, when here, right? That would mean, oh, we forgot to we need to keep track of the index of all the characters, right? Yeah, we use indices. Just use array. Okay, we need to push to the indices also. Push, which means character and I. Okay, if it is possible result, then the indices, the possible here, the substring from A to B here will be a possible result, right? So possible result would be as a slice indices 0, 1, and indices that's length -1, 1. Okay, slice should +1. Okay, this is the possible result. If result is empty or it is shorter, is smaller than result and length, we should update result, right? Yeah, we just update it, and now we should unshift the first one, right? Remove the first A. Now we remove the first character. Index. Okay, indexes. We say the first would be indices 0. Okay, now we should say indices unshift, which remove it, and then we need to update the count. Right? The first thing is that the count should be updated. Count set first index 0. We set it to count get first index -1. Update the missing, right? It may be because we remove A, now A become missing. So if count get first index smaller than target get first index. Then you become missing again. Missing characters, we need to add it. Add this one. Okay, so we check the possible result and update it. Now, but actually, if we remove it, it might be still possible result, right? Like say we have we're going to find A, B, C. Now we're missing A. Minus B, C, B, C, A, right? Now we have A. We remove the first one, which is C, B, C, A. It's still valid, still possible result. So we use a while loop to check over and over again, right? So it should be while missing characters, but there's still no missing characters. We just do it and update it over and over again. And finally, when all this is done, I think we can safely return result. Let's run the code. Oh, there's some typo here. Missing characters remove is not a function. Oh, for set is delete. Of course, we meet the error. Okay, so let's see what's the problem is. We unshift, we push, we output A, B, or C. Okay, let's see. Let's look at our code. We return ADOBEC, which is the first possible result. But then ABC, we should go to BCBA, right? This is still a possible result. And finally, we go to ABAC. Okay. Let's log something. Check slice 0 I plus 1. And then also log possible results is this, and the missing size we log it and run it again. We have a God. We got the log here, like okay, we check ADOB, and we got ADOBC. We have nothing missing, so it's possible result. And then we go to O. We're missing A, right? Yeah, we'll go to finally we go to A. We miss nothing. It's possible result. Oh God, the slice. Possible result. It should not be ADOBC here. We already unshifted. Indices 0, 1. We push I. We have a problem here. Why it's Okay, we first we got the ADOBOCC. We need to unshift. We did shift. Log here, possible result is this, and then the indices. Log the indices also. Okay, ABC here, ABCBA. So there's no my bad. It's shift, not unshift. We try it again. Cool, where we have the right answer. We comment out the log and try to submit. By the same time, we analyze the here A, and we except it should be something empty. Wait a minute. We also dump in a log. The input should be A and AA. We run the code. For this problem, I did do something like preparations for this problem, but when I'm recording this video, I'm trying to rewrite it with a totally fresh new mind, with a better understanding this problem. So the program, which is not actually the code which I submitted and got accepted, so it might be there might still be some problems there. So checking A, yeah, missing 0. Why? Missing should be maybe the target is wrong. Okay, we log down also the target count missing characters. He says the target should be A1. It should be 2. Wait a minute. For T equals A double A. My bad. It should be TI. Oh yeah, now we have the problem. Have the right answer. Let's try submit, and we need to comment out the console log. The time complexity for this one here, it would be, okay, we're accepted, but not fast enough. Here is ON, like the S is N and M. For here, we got OM. Here is ON, yeah. For each one here, target has, which is direct, which is hashable, so it's direct access. It's okay. This is okay. This is okay. And we use an indices for the worst case. We have the space of ON, right? For each number, we have pushed into the worst. And the missing characters, this is worst ON, OM. Okay. Count worst OM target. Worst OM. Okay, for here we have a while loop here. Actually, for each possible items in the indices array, it will be checked. It will be first pushed it and then removed, right? So actually, it will just be only checked for maximum twice. First one pushed, the next one popped. So okay, this will be another problem here. And index here, okay, here, okay. So actually, this should be time would be O n, I think. Space. We use worst indices is worst. Okay, I don't know. It's a O like 4 3, yeah, 3m plus n. Nah, worst. I'm not sure I'm getting this right. And by the way, this is very slow comparing to other solutions. But maybe the indices here could be improved. Like we can keep one index of left rather than push and keep tracking of it. We could just move the cursor from left to right. Anyway, so I think I'm going to give up here. This is the acceptable answer, which is not the best, maybe, but hope it helps. And let's try do something else. Hope and see you next time. Bye bye.